Hi, everyone. I like how you put it. This talk is really about how two separate IoT technologies can help you build even better products. So it's like how those two can be better together. And it's not about necessarily which technology is going to win, but how you can use different ones to build the best product. So my name is Don Garnier. As Olivier said, I am a co-founder of Blecon. And at Blecon, we build solutions so that our customers can roll out Bluetooth networks and get data from Bluetooth devices and their beacons into the cloud, into their data-driven applications. So we have a booth just here. So if you want to come and have a chat after the talk, I'll be really happy to talk to you about Bluetooth or anything IoT related. So this story starts quite a long time ago. I had a small company in the IoT space a bit over 10 years ago, and I was involved with a customer who had a great new product, which was an irrigation valve that they could deploy into fields, and more specifically in sugarcane fields in the Indian Ocean, where the use of water was a key challenge that farmers had back there. So they had that new product, which was using a cool new technology at the time, which was called LoRa, that became quite successful, as we know now. But it was really the early days. And so they would send out a team to set up a mast in those fields to provide LoRa coverage, and then they would install those irrigation valves. And then that's when the problems would start, because basically those installers who were in super 45 degrees heat, in those fields, and not very comfortable conditions, where they didn't know if those valves worked, because they'd plugged them in, and then they didn't know if the valve could connect to the LoRa network or not. So what would they do? They would pick up their phone, call back the office in Europe, and were like, hey, can you check if my valve has sent something in the past 5 minutes? And quite often the answer would be, no. And then they would have to wait another 5 minutes, because those valves would only communicate once every 5 minutes. And they were like, OK, is it working now? No, still now. Maybe try and move the valve somewhere else, right? So that was very painful. And then if they got lucky and the valve could communicate, the other thing they needed to do is make sure that the valve could actually perform its function, which was opening and closing, so that water could flow in those pipes. And same process. Pick up the phone, hey, can you queue a command to trigger that valve to open? And then they would wait, in the heat. OK, that probably worked. And then, OK, can you close it now? Wait another 5 minutes. So that was a massive pain. And also that meant that they had to send out some pretty sophisticated engineers who had some knowledge about the ins and outs of the product to set up those valves, right? It was and they had to fly them out, right? It was totally impractical. So what did we do? Well, at the time, we had a big debate with the engineers. We're like, oh, maybe we could add some buttons on the device. But those had to be watertight devices. So adding a button would have been a nightmare, because that would have compromised the water tightness, or the cost would have gone up massively. So what did we do? Well, we did something else, which is adding Bluetooth into those devices. And we built a little app that installers could use, and it could connect to the valve and then check, OK, is it communicating with the LoRa network? Yes, that works. I know it works. Maybe I'll trigger sending more messages, right, to make sure that the link's reliable. And then maybe now I can open it, and then the valve would open instantly and close instantly. Sounds very basic, but that was really a killer thing, because then suddenly they could, instead of having sent someone out, they could just put one in the mail. And then the farmer with their phone would be like, yeah, OK, I'll set it up, plug it in, and then I'll run the test on my phone. Yeah, that's fine. So that was really, really life-changing. So going back to what made LoRa such a great technology for the IoT, well, we're like, again, a lot of people in this room like will be familiar with it, but it's very extremely power efficient. You can achieve huge range, so it's great because with like one gateway, then you can cover a building or a field. But my personal favorite is that you can deploy your own infrastructure, and I think it was really like a strong differentiator for LoRa and LoRaWAN that you could deploy the coverage where it mattered. Looking at Bluetooth, also a great technology for IoT. Also super power efficient. It was called Bluetooth Low Energy for a while, so it was even in the name. As Damon mentioned before, it's actually like pretty fast. Like you can achieve really high data rates. Like by default, the PHY gives you 1 megabit per second. There's also a PHY that gives you 2 megabits per second. It even works ongoing to increase that throughput further to almost 8 megabits per second. It also benefits from huge economies of scale, which means that adding Bluetooth to your device is very cost efficient. But Bluetooth also has a superpower that very few technologies do have, which is the huge pervasiveness of Bluetooth, the huge scale of it. It's in virtually every mobile phone, or not even virtually, it is in every mobile phone. It is in all laptops. And if you look at the sheer number of devices that are being shipped today that have Bluetooth in them, it's like insane. And the growth rate is huge as well. And I bet you that there are more Bluetooth devices in this room than people. So what does that mean for IoT? That means that there's a huge opportunity to use Bluetooth for IoT, and you can build Bluetooth IoT networks as well. And because like Bluetooth is everywhere, it means that with every human, there's like Bluetooth coverage around them, and you can reuse that to opportunistically send data over Bluetooth back to the cloud. So this talk is about how Bluetooth and LoRaWAN can be combined to create amazing products. So if I was going to build an ideal LoRaWAN plus Bluetooth device, here are like the sort of two data buckets that I would fill and assign to each technology. I think LoRa would be very natural for anything which requires like timely, low latency events, alerts when the device is unattended. Something requires attention. So I would put all of those things in the LoRa bucket. For Bluetooth, it really shines for things where you're in front of the device, so you need like fast feedback. So things like commissioning that I mentioned earlier. But also rich data sets, which are very important, but maybe not as urgent. So things like rolling out firmware updates or getting telemetry from your device. And what would it look like in terms of device lifecycle? Where, you would set up your device, and there's that commissioning phase, and you're next to your device, right? Physically close to it. You pull the battery tab, and it's on. When that happens, you can perform a lot of tests over Bluetooth. That includes like testing a LoRa connection, so you can trigger like sending more LoRa messages in that time. But maybe the device, like your firmware has evolved between the time it left the factory and when you're setting it up. So the firmware can be updated as well. And then your installer leaves. The device sends a little LoRa ping or heartbeat every now and then with like alerts or important events back to your backend. And then comes the time where you need to change the battery or need to service the device. And once again, you have Bluetooth coverage. So that's the time when you can download all the telemetry that the device collected. And you can upload a new firmware as well, for instance. So this is a very LoRaWAN focused example of a use case that can be much improved using Bluetooth if you have that in the device as well. That activation by personalization phase, which is basically how you register your device to your LoRa network. Well, if you have like a mobile phone next to the device, you know where the device is because the phone has GPS, right? So you know where the device is, you know which network, LoRaWAN network to select. And then you can send the relevant data to the device and to your LoRaWAN server to register that device to that server. Next obvious step is basically just checking the quality of the LoRaWAN link. Is the right data rate in use? Is my link budget good enough? Because you don't want to set up a device that maybe works, but not that well, so the battery will be drained much faster than you expect. So you can test all those things at that point. Another use case, which is very topical, is using Edge AI on your device. So Edge AI, I think of it as a great compression technology, right? The amount of data which you can that an Edge AI model can consume and turn into a byte of valuable information is very impressive. And it's great to use in a low-power device because processing data on the device is much cheaper in terms of energy than trying to send it and do the processing in the cloud. So I think it fits really well with IoT. So let's say you're trying to do anomaly detection on some machinery you're monitoring. So your device can be ingesting a lot of data that comes from an accelerometer and turn that quite significant sample of data into everything is okay, or actually, no, that thing needs attention and you need to come. And you can send that 1 byte of data over LoRaWAN that fits very well. The issue is that sometimes your model will give you an answer which is, I don't know. Maybe the machine is fine, maybe it's not. And that's where having Bluetooth becomes very interesting, because you can store the raw samples in your device, and then at the next opportunity when you have someone that walks past with Bluetooth phone, you upload the raw data to your ML platform. And then your data team, your ML team, can look at that, get that refined data set to improve the model, and roll it back to your device so that you have better coverage of all those scenarios that you might encounter. So it's great for making sure your model stays up to date and gets more and more refined. Another use case that actually we've seen a lot where using Bluetooth is very successful is that sort of customer support or after sales scenario where someone is in front of your device and they're like, hey, customer support, my device is not working, right? Well, in the background, you can get a lot of telemetry from your device, you can get crash dumps, you can get logs, and that gives all that rich data to the person on the other end to be like, oh yeah, I think I understand where the problem is, as opposed to just relying on the customer saying, oh yeah, I tried to do this and then that didn't happen, which is not very useful, right? So that can generate a lot of cost savings, right? If you don't have if your customer is not shipping the device back to you, or that prevents you from having to send someone on site, that can make things much more seamless. And by the way, now that Nordic have acquired Memfold, they've released a developer tier that, for getting telemetry and crash dumps in the cloud and analyzing them. So that type of technology is becoming more and more accessible to IoT developers. Actually, I sort of lied in the sense that you don't even want your customer to have to pick up the phone to tell you your device is not working. What you really want to do is making sure that your device stays up to date and those bugs are fixed without your customer even knowing. So if they're going past your device, doing something else, for instance, the farmer is doing his rounds in his field, and they have their mobile phone in their pocket, then you can opportunistically also roll out things like over-the-air updates. and get that data transfer to happen in the background, which can be, once again, like a great tool to use to extend the lifetime of your device. You don't have to ship a new device, right? Great. So that hybrid device, if we're looking at it from more an architectural standpoint, you might be familiar with how your device would communicate through the LoRa network over a gateway, a LoRaWAN server, and then you have a cloud application that orchestrates everything. Where you can build the same thing on the Bluetooth side, right, and make it look very familiar to the developers, both on the device side and on the cloud side. You can have your device communicating with a Bluetooth phone, which has a mobile app that gives you that functionality that's orchestrated by a Bluetooth network server, and then communicates as well with your cloud backend. So you don't need to learn like a new paradigm. It can be made quite transparent in terms of how your developers can work with a solution like that. I've been talking about Bluetooth plus LoRa, but is it something that actually exists in the industry? Well, I did just a quick search over what the exhibitors, or some of the exhibitors at the Things conference have in their line card. And I was actually quite surprised with how many devices showed up. And I'm pretty sure I missed a lot of those. So if you're an exhibitor and I missed your device, please come and tell me about it, because I'd be quite keen to learn about it. And that's very natural, right? Because if we go back to my use case from 10 years ago, a lot of other companies came to the same conclusion. Bluetooth is great as a combination technology for LoRaWAN devices. So I have things like modules, trackers, temperature sensors, radar sensor. Like the pervasiveness of Bluetooth in those devices is insane. And that also comes from the fact that, adding Bluetooth device has a very reasonable cost, right? So, to conclude, I think in the spirit of what the panel said is that, I think we're, as an industry, we've gone past the sort of this technology is better than this. If you're a system integrator and faced with a customer problem, then you really want to have different tools in your toolbox that you can pick from. And some technologies fit really well with some use cases. And I do believe that for some use cases, actually, you might want to consider combining two technologies together to really enable those customers and fix their problem. So it's not about which one is better. It's like how do you use all those amazing technologies to build great products. And in the case of combining Bluetooth plus LoRaWAN, one of the key things I want to leave you with is that it can really help you reduce your operational costs by saving you a lot of money in terms of getting customer returns or sending people in the field to diagnose your devices. It can also really simplify the initial deployment steps compared to a LoRaWAN-only device, and give your users the ability to do a lot of self-service tasks. But maybe more importantly, maybe that's the most exciting part, is that your device's lifetime can be extended. Because if you have that constant cycle of telemetry, insights coming back from your device, and an ability to roll out firmware updates, to fix bugs, enable new features, differentiate features based on your customer's actual use case, then that can be a really killer feature where you can have the same hardware that performs different functions, and that can bring a lot of agility to your way of developing products. So please come and have a chat if that's something that resonated with you. I'll be very happy to talk about LoRaWAN or Bluetooth or a bit of both. Thank you.